through this. So, humble apologies again, but we'll start and we'll carry on with the discussion. And we'll start the discussion with the portion of the ozone layer. Okay, so I hope everybody is fine now. All the grievances, whatever grievances I was seeing in the comment section, please cool down, have a sip of water, and then let's continue with the discussion. So, hello, very warm good evening to all of you, and welcome once again to Byju's Exam Prep. Now, yesterday we have had a discussion about the portion of air pollution, where actually in the discussion we had carried out the principled argument about what is stubble burning, why that stubble burning happens, what are the reasons why the northern part of the country is much more polluted as compared to the southern part of the country. And we have taken a look at the variety of measures and variety of reasons rather, from the basis of, let's suppose, the aspect of economic factors, from the aspect of the human geography factor, that is the aspect of policy. And please understand here, guys, yesterday I was going through few of the mails also. Now, what I could summarize from your level of understanding was that when you think about stubble burning, most of your thought process is only restricted to the rice, wheat, and only the MSP. While that is a pertinent issue, but please understand you have to gain an advantage over your competition. So if you are writing an answer about that aspect of stubble burning, why that happens, you have to talk about the groundwater legislation of Punjab also. You have to bring into question the aspect of the crop diversification factors also. So that is where you have to basically marry all these particular single snippets and then frame a story. Please ensure you do that. Then after that, while we were carrying out the discussion, we also discussed about what can be the remedial measures, where we talked about the alternate fuel technology, how alternatively more fuel can be different types of fuel such as hydrogen, green hydrogen, for example. Now we have also talked about what is green hydrogen, then vehicle scrappage policy, how that will help, graded response action plan, that is depending upon what is the level of pollution you take a particular action, and these are your remedial measures, right? Now what is it that we are going to do today? Today, basically, we are going to read about the ozone layer, and we are talking about the good ozone here. Another important topic that I want you to stress upon multiple times, I want you to revise before particularly your mains exam, is the ground level ozone and photochemical smog. That is one of those favorite pet areas of UPSC. UPSC has certain favorite pet areas. There is, when you appear for the state services, they have those favorite pet areas in almost all the subjects. In case of UPSC, only few topics are there where UPSC tends to frequent those particular topics, and it would be absolutely foolish on our part as candidate, as an aspirant of civil services, if we start ignoring those areas. So please don't ignore those areas. For example, in the portion of environment ecology, in the prelims examination, generally you find questions about ecotone, ecological habitat, and that is where you find the species-centric questions also. Okay, so those are your favorite areas that UPSC will ask a question. Now, coming to the portion of the ozone layer. Now, ozone layer is present where? Here, we are talking about the region of stratosphere. In the region of stratosphere, you have a thick layer of ozone gas. So you have a kind of a, let's suppose this is the top of troposphere, this is your tropopause. Now above that tropopause, you have a thick layer. It is not thin in any proportion, it is thick, of many kilometers altogether. So this is where you have the ozone layer, which is also referred to as ozonosphere. Now, when we say ozone, we are basically talking about oxygen itself. But the ozone molecule, rather than the oxygen that we breathe in, the oxygen that we breathe in is what? O2. Now, in the case of ozone, you have O3. So how is that O3 produced in the first place? So that O3 or ozone, why is it that you have that thick layer of ozone in the region of stratosphere? Why not in the region of troposphere? I'm sure you would have thought about these queries. I'm sure you would have thought about these questions also. But it is basically in the region of stratosphere, up till the region of stratosphere, you have a significant penetration of the ultraviolet rays of the sun. And listen to this carefully. Up till the region of the top of stratosphere, you have the penetration of ultraviolet rays of the sun. Now, these ultraviolet rays of the sun, when they will hit these oxygen molecules, right? In that situation, in that particular case, there will be the combination of these oxygen molecules and oxygen atoms in a way where they end up producing ozone, right? So significant density of oxygen molecules, when they are hit by the ultraviolet rays of the sun, that is what produces ozone. Okay, yes, Shalu, good. So in stratosphere, presence of UV rays hitting the oxygen molecules or oxygen atoms lead to the formation of ozone. And that is where this ozone and this ozone layer tends to absorb these ultraviolet rays and also tends to basically re-reflect back these ultraviolet rays, thereby protecting the planet and the surface from exposure to ultraviolet rays. That is where the protection is basically offered. So that is the case of the production and the formation of ozone layer. Having said that, natural factors are also there, but mostly for the past few decades, that is since 1950 onwards, when you had an advent of cooling systems, refrigeration systems, etc., in the western part of the world, that is in the Western Europe, North America, etc. Now, all these cooling solutions, refrigeration solutions, etc., they would use a particular chemical or a type of chemical, a kind of chemical, what we refer to as CFCs or chlorofluorocarbons. Chlorofluorocarbons. Now, these CFCs, they would be used in fire extinguishers. These CFCs would be used in refrigerators. These CFCs would be put to use even in your air conditioning units. So these CFCs started being used in a widespread manner. And as a consequence of that, as these CFCs would be slowly and steadily released into the atmosphere, these gases, they tend to maintain their structural integrity for a very long period of time, as in they are persistent in the atmosphere for a very long time. Remember, yesterday we talked about black carbon, and in black carbon we saw that it is a short-lived climate pollutant, that it lives in the atmosphere, it stays in the atmosphere for a very short duration. When we talk about these CFCs, they can stay in the atmosphere for a very, very long period of time. So thereby, due to atmospheric circulation, these CFCs, they are carried up higher in the region of tropopause, and sometimes slowly and steadily, they also penetrate and leak into the region of stratosphere. Now, these CFCs, they become chemically active at low temperatures. Remember, they are used as coolants, they are used as refrigerants, right? So they become chemically active. Become chemically active at low temperatures. Right. So this very significantly low temperature is not experienced near the ground surface. We are talking about minus 50, around that kind of a temperature, minus 40, minus 50 degrees Celsius. That is when they become chemically active. Now, sometimes what happens is that these ozone molecules, they rise up, these penetrate, and they react with ozone. The CFCs, they react with ozone. Now, when they react with ozone, I will show you the chemical reaction also. So what happens actually is that in this, the chlorine part of it, that chlorine part of it, it breaks the ozone molecule. It converts the ozone into O2 plus oxygen radical, right? And you have chlorine, which basically is the reactive one. So it consumes the ozone. Now, when the ozone is converted into oxygen, that is O2, now that oxygen doesn't have the protective properties. It cannot protect you from the ultraviolet rays. The ozone molecules, they can protect you from ultraviolet rays. That is why the ozone layer protects you from these UV rays. But if this ozone is converted into O2, then it won't have that level of or any kind of protection from the ultraviolet rays. So over a period of time, what starts to happen is that the concentration of ozone in certain areas, that starts to deplete. The concentration of ozone in a particular region, that starts to get depleted, right? So the ozone layer that you see, that ozone layer becomes very thin in certain portions. That means the concentration of ozone molecule lowers quite significantly in certain areas due to reaction, right? Now, by the way, how do you measure the concentration of the ozone layer or of the ozone molecules? So the concentration of ozone is measured by a unit that we refer to as the Dobson unit. Dobson unit. So that Dobson unit gives you an idea about what is the amount or the concentration of ozone molecules in any particular region. So when the concentration of ozone molecule decreases, then what happens is its ability to filter out ultraviolet rays, because if you think about ultraviolet rays, much of that is absorbed by the ozone layer and some of significant amount is reflected also. The UV rays which come back or which fall, they are reflected also. Now, sometimes what happens when the thickness gets very, very less, in that case, their ability to filter out the ultraviolet rays decreases. And the ultraviolet rays then fall upon the ground surface. So this region where the concentration is so very less that it won't be able to protect us from the ultraviolet rays, this is what we refer to as ozone hole. This is what we know as the ozone hole. So when you hear about the term ozone hole, it is not the case that ozone molecules are completely absent in this region. Absolutely not. Ozone hole basically talks about those particular regions in the ozone layer where the thickness is so very little, so very less, that basically it won't be able to carry out its purpose, that is to filter out the UV rays. So that is where the ozone hole is in existence. Now, we do know that these CFCs, they need a trigger to become reactive. Now, one of the catalysts for that reaction is very low temperature. When you take the temperature to very low conditions, that is when they will be reactive. The other important trigger that we require is the presence of UV rays. When the UV rays, they fall on the CFC, they become very much reactive. So that is the reason why they will interact in the stratosphere. Now, when we talk about the region of the area around tropopause, we do know that temperature is an important factor for triggering this reaction. Now, where is it that we expect the lowest temperature to happen? We expect generally the lowest temperature to be observed around the region of poles, isn't it? Around the polar areas, you expect the lowest temperature to be in existence. So around the region of the poles, that is the reason why around the polar areas, you will find that these chemicals, whenever they reach the polar area, it will take its own due course of time to reach the polar areas, but the atmospheric circulation will carry it in some parts of the polar areas also. Now, when they reach the polar areas, that is when it is very favorable to trigger that reaction. That is the reason why the ozone hole that you see, it widens during the polar winter. For example, right now, you have the polar winter in the Arctic region. So the ozone hole right now in the Arctic would be significantly more prominent. But right now, you don't have a kind of a cold condition in Antarctica. It is cold, but in comparison, it is not the Antarctic winter as of now. But there, that is why in this season, the ozone starts repairing itself. Okay. Now, here, you might have another kind of a question, that is this ozone hole created only in the polar areas? That will be very weird. If you have this hole created only in the polar regions, nowhere else, that will be very, very weird. How can it be possible? So it is not the case that ozone hole will be found only in the polar regions. They are very prominent in the polar areas, but you have other areas across the tropics also where some amount of ozone hole is in existence, or some depletion of ozone also takes place in other areas. Okay. Now, here you might have another query, or if you think about it, ozone is naturally produced. If you have oxygen molecules, ozone is naturally produced in the advent or when you have ultraviolet rays hitting the oxygen molecules. And ozone is consumed also. So it is being produced also, it is being consumed also. So if both the processes are taking place simultaneously, then why do we have a depletion? Why do we experience a kind of a depletion of the ozone layer? That is primarily because of the fact that when we talk about this oxygen or the rate of production of ozone, that rate of production is very slow as compared to the rate of reaction, chemical reaction. Or in a way, excuse me, in a way, we can say that the rate of consumption of ozone is much higher as compared to the rate of production. That is why you have large gaping holes which are created. Now, that is the detailed background about the ozone hole and the ozone layer, more detailed than you will find anywhere else. When we talk about this ozone hole, the scientists since the 70s itself, when you had the space missions which started being launched, satellites started being in orbit, at that point of time itself, people started studying the atmosphere. And when they studied the atmosphere, they were very well aware that there is this ozone layer that is getting depleted at a very fast rate. And the scientists were able to single out as well that it is these chlorofluorocarbons which are used in refrigeration, air conditioners, etc. And this chlorofluorocarbon is leading to that kind of a depletion. So that is where the global consensus was building up in the 70s itself, that we need to do something in order to prevent this. So a global awareness movement had started. And please understand, by the 80s, when we are talking about refrigeration, when we are talking about air conditioners, do you think countries like India, China, we had these particular problems? Absolutely not. If you ask your grandparents or if you ask your parents, 70s and 80s, it was a big deal to have a full electrified house and have fans and TVs. That would be a very big deal. So India at that point of time was not in a stage where air conditioning units would be installed in every households. So we are the emitters of these CFCs. Absolutely not. In fact, that stage reached very recently. We have reached that level very recently, where the per capita income has increased substantially, where you will find air conditioners installed in large number of houses now. So that was not the case in the 70s and the 80s. So when the world community was talking about preventing the emission of these CFCs, they were largely targeting the Western countries. And they are the ones who are responsible for this kind of a depletion. Now, in 1985, people got together at Vienna and they signed a convention where they talked about the conservation of or protection of the ozone layer. Please don't confuse it with the Vienna Convention for the diplomatic immunity. That is different. This is a different Vienna Convention. So this Vienna Convention basically talked about how to conserve, or we need to protect the ozone layer. As I told you, convention is where you set a larger aim. But how to achieve that? You do that by target setting in the case of protocols. So that Vienna Convention came into existence. And it was followed in 1987 by setting the terms of how do we reduce these emissions of the ozone depleting substances. Ozone depleting substances also referred to as ODS. How do we reduce the emission of these ozone depleting substances so that you don't have the ozone hole getting created anymore? Now, Montreal Protocol was very unique, is still considered to be very unique, because Montreal Protocol is one of those international agreements where you have the largest participants, almost 180 plus countries are signatories to the Montreal Protocol. Now, this Montreal Protocol, when it came into existence, it had a kind of an open-ended wording which was open to getting amended. So Montreal Protocol went through various different amendments. And the scientific community is much more smarter than the politicians. Everybody knows that. And industrialists and the capitalists who basically work upon these scientific innovations, they are even much more smarter than what the politicians can think about on any day basis. So basically, when the world governing body, they started talking about banning the CFCs, the scientific community had to come up with an alternative, because all the air conditioning production, refrigerator production, that could not be halted at a sudden. So they started using alternatives. The industry announced it with a lot of fanfare that, we have found an alternative to CFC. We have HCFC, hydrochlorofluorocarbon. This is safer. Now, very soon it was found out that even this has got the ozone depleting potential. The Montreal Protocol went through an amendment where HCFCs were added. Then furthermore, it was found out methyl bromide, that can be ozone depleting. It was added. So the beauty of Montreal Protocol is that as and when the scientific innovations have taken a leap, the protocol has kept pace with that. As and when the industrialists, they have found a way to circumvent the regulations of the protocol has kept an amendment, has brought in an amendment to ban that. Okay. Now, it was later on when it was found out that these HCFCs, then bromofluorocarbons, all of them, they are depleting the ozone. Right? Now you had carbon tetrachloride, etc. They are depleting the ozone. Then it was basically the HFC, hydrofluorocarbon. This was a new chemical which was innovated, and it could carry out the purpose of refrigeration coolant as well, without having a potential to damage the ozone. So HFCs, they started being used across the industries. But then again, later findings, they basically indicated that while these HFCs, they will not deplete the ozone hole in itself, they can cause substantial amount of global warming. That is another issue that we are fighting. So we cannot start using a chemical which will basically not deplete the ozone layer, but will destroy the planet by warming it up. So these HFCs also, they have been planned for a phase out. That is covered under the amendment to the Montreal Protocol, that is the Kigali Amendment. Okay. So when you have the portion of ozone layer that you need to study, you need to be aware of what is this ozone layer, where is it to be found, what is its purpose, how is it that ozone layer has been produced, has come into existence, how is it that this ozone layer can lead to certain benefits by preventing us from the exposure to UV rays, why it is getting depleted, where it is getting depleted, and if it is recovering, why it is recovering, along with the Montreal Protocol and the Kigali Amendment. Okay, now let us take a look at it, detailed look at it. I hope till now you are comfortable. So much of the ozone that we see is concentrated in a portion of the stratosphere called the ozone layer, which is found roughly 17 to 26 kilometer above the sea level. Now, most of the stratospheric ozone is produced when some of the oxygen molecules in the layer, they interact with the ultraviolet rays emitted by the sun. That is how they are produced. Now, observe this. You observe a kind of a gaping hole of sorts above the region of Antarctica. So this is what we refer to as ozone hole. Okay. Now, how is it that this chemical reaction is basically triggered? Now you have these CFCs. Now CFCs will have chlorine atoms also. So when they are exposed to UV rays, over the exposure of UV rays, this chlorine exposure to UV rays, whenever that happens. So as a consequence of that, what happens is basically these CFCs, they get chlorine gets separated and becomes reactive. Okay, they become significantly reactive. And that is when you can see that the chlorine, it combines with ozone molecule, and basically it breaks this ozone molecule into chlorine monoxide, and then you have the oxygen. So here if you observe, the O3 has been converted into O2. Now O2 is not harmful, but it will not solve the purpose of ozone. The purpose of ozone is to filter out the ultraviolet rays. That won't be solved by O2. Meanwhile, this chlorine combines with another free oxygen radical and thereby forms the chlorine atom again, and again O2 is produced. Now this chlorine that you see, it is free to react with another ozone molecule. It is free to react with another ozone molecule. So as a result of this, it triggers a kind of a chain reaction. Triggers a chain reaction. And when we say it triggers a chain reaction, basically this chlorine atom, which will keep on breaking the ozone molecules, and again it will be free to react with another ozone. So the rate of consumption or the rate of this reaction, the rate of destruction of ozone is much faster as compared to the rate at which the ozone is produced naturally in the stratosphere. So this is almost the kind of overall the chain reaction that you see. Here you have the oxygen. So basically what you see, that CFC, for example, CFCl3, now when it is exposed to ultraviolet rays, that is when CFCl2 separates with a chlorine atom. Now this chlorine atom is ready to react with the ozone molecule. When it reacts with the ozone molecule, it produces chlorine monoxide and oxygen as a byproduct. Now this chlorine monoxide will react with another free oxygen radical and will produce a chlorine atom as a byproduct. This is going to react with another ozone molecule. So this goes on happening, and that is where the whole ozone hole gets created. Now, as I told you, when we talk about why it is getting depleted, why the ozone layer is getting depleted, so you have certain substances which come into the category of what we refer to as ozone depleting substances. Now, these ozone depleting substances, CFCs, to be used in solvents, dry cleaning agents, air conditioners, refrigerators, halogens, the halon group that is there. So, for example, the fluoride, bromide, chloride, etc. They are used increasingly in the fire extinguishers. Carbon tetrachloride, again, fire extinguishers and solvents. Methyl chloroform. Now, slowly and steadily, as the world got to know about more of these chemicals which can damage the ozone, Montreal Protocol has been amended regularly in order to include these chemicals and to ban these chemicals also. That is the reason why Montreal Protocol is so successful. Okay, not all the protocols across the world, for example, Kyoto Protocol has not been that successful, but Montreal Protocol has been so successful that the ozone layer is now recovering. It is expected by the 2060s we will reach the level of ozone which was there in the 1970s, before that depletion started happening at an exponential rate, right? So these are your chemicals which cause depletion of the ozone. So you have the ozone depleting substances. These are your ozone depleting substances, right? Example, CFCl3, etc., methyl tetrachloride, and so on. But there are natural factors also. Some of these natural factors, they are so very influential that they will lead to depletion or damaging of the ozone molecule. So which natural factors are we talking about? For example, when you have volcanic eruption, let's suppose, whenever you have volcanic eruption, now in the event of a volcanic eruption, significant amount of the matter, significant amount of the gases, the clouds which are produced. Now, all these gases, all these clouds, basically, they end up pushing through, and they go up to, and they rise up to a very great height. And that is where they will deplete it. Okay. So that is where, when you have, for example, I might have told you this before also in the geography classes. For example, when you had the Tonga eruption, the Hunga Tonga Hunga Apai eruption, which happened in December 2021 to January 2023. Now, when that eruption happened, now smoke, the plumes of smoke, the cloud emitted was so significantly higher. It reached beyond mesosphere also. So think about it. If with that force, the air rises up, if that with that force, ashes and the gases, they rise up, they will puncture through the ozone also. But other than that, you also have events such as massive forest fires. Now, these also end up producing high level clouds in many of the cases, where you have the gases, the pollutants which stay in the higher atmosphere, and they slowly and steadily. Now, forest fires also produce volatile organic compounds. So these volatile organic compounds slowly will puncture into the ozone and thereby cause the depletion of it. So these are your causes. But once that ozone hole gets created, thereby the impact of it is that now the ground surface is exposed to ultraviolet rays of the sun. Yes, meteorites can also cause that, but meteorites are a very temporary phenomenon, but it can cause, yes. So here you can write meteorites also. Okay. Now, when we talk about it, basically, once the ground surface gets exposed to ultraviolet rays of the sun, the impact of it is widely felt over amongst the plant species, amongst the animal species. For example, many of the plants, when they get exposed to the ultraviolet rays, so if let's suppose you consider a leaf, let's suppose you consider a leaf here, right? Now, in that situation, when you have the ultraviolet rays which are exposed, you will observe wilting of leaves. Slowly and steadily, yellowing on the sides will start happening. As a result of that, the productivity, the amount of uh, food or amount of the organic matter that the leaf generally produces as a result of photosynthesis, that gets reduced. So the plant productivity reduces, right? Plant productivity reduces. Now, when the plant productivity experiences a reduction, overall, many of the plants, they begin to die, right? And that means there is not enough food. The net primary productivity across the world, that starts going down, which is going to be very impactful in terms of the food chain, in terms of the energy pyramid that we have studied. So there, the impact which will be felt will be humongous. Other than that, you have many different animals. Now, when they reproduce, now you have few of the animals where at the larval stage they get exposed to the solar rays. Now, if at the larval stage, larval stage means when they are in a larva, when they are still a larva, right? Or the larvae when they are present. Now, when they get exposed to the ultraviolet rays, many of these larvae, they are unable to survive. Many of the young ones, they are unable to survive. Also, the kind of sex determination, the sex variation, that also happens. You have a predominance of male in certain cases, in a certain amount of the newborns, you have a predominant male species which are to be formed. So that is where the animal life is also impacted. We humans are also impacted by the depletion of ozone, because when we get exposed to ultraviolet rays, our skin, that is the surface which gets exposed. So our skin starts developing lesions. Our skin basically starts developing certain kinds of deformities. It can also lead to skin cancer eventually. So these are basically your harmful impacts, the harmful impact of the ozone hole depletion, or basically the harmful impact of exposure to the ultraviolet rays of the sun. Now, here, in order to basically mitigate this, you have the Vienna Convention initially, which formalized the international cooperation of ozone issue by creating framework for protection of ozone layer. It entered into force on 22nd of September 1988. You don't have to. So from now on, whenever we study about the conventions and protocols, please don't start learning when it came into force, when it was ratified. Not required, not important. Unless and until a current affairs development takes place in that. Other than that, please don't go through it. Okay. Now, in 2009, it became the first convention of any kind to gain universal ratification across the globe. Now, this Montreal Protocol this Vienna Convention was basically followed by a Montreal Protocol. As I told you, convention basically gives a larger goal setting, larger aim setting. But when we talk about how to achieve that goal, you need a protocol in action. So that is why you have the protocol to every convention. Almost all the conventions will have some or the other protocols. So here, this Montreal Protocol was on substances that would deplete the ozone layer. And it talked about phasing out the production and consumption of ozone depleting substances in a kind of a phased manner, not at one go, because that would be simply impractical, but in a phased manner, you basically reduce the amount of production. Now, a multilateral fund was established in 1991 for implementing the Montreal Protocol, and the purpose of it was to provide financial and technical assistance to the developing and the underdeveloped nations of the world, who basically had to adapt to newer chemicals, etc. Because they don't have the manufacturing prowess. The developing countries, they don't have the research base where they can come up with an alternative, right? For example, tomorrow an important industrial chemical is banned. We might be in that stage where we might come up with an innovation, but chances are that other countries will outrace us, depending upon the level of scientific advancements that you observe in China, in US, in Western Europe. Chances are that we will be edged out of the race. So in that situation, who is there to help countries such as India, countries such as Bangladesh, to adapt to the newer system where they can replace these chemicals? Because please understand, when we talk about the tropical countries, the countries within the tropics, the temperature throughout the year is so very high that the refrigeration and the air conditioning needs is going to rise up with the coming day. Every day, the summer, or every year, the summer is getting more warmer and more intense as compared to the previous year. So our requirements are very high. So we cannot simply do away with the ozone depleting substances. We need an alternative. And for that alternative, we need support, financial and technical support both. And for that purpose, the multilateral fund was established. Now, this fund is implemented by various different member organizations of UN. You have UNEP, United Nations Environment Program, UNDP, World Bank, and United Nations Industrial Development Organization. All of these are participant in this. Okay. Now, this Montreal Protocol, as I told you, is very unique in the sense that it has kept pace with the development in the scientific community. And that is where the various different amendments of the Montreal Protocol, they indicate that. Now, you don't have to ratify or mug up these particular amendments, but it would be better if you are aware of it. If a question is asked about the Montreal Protocol in the mains examination, it would be very advantageous for you if you are simply able to highlight in small bubbles about the various different amendments. So first of all, you had the London Amendment. Now, the London Amendment, it changed the ODS emission schedule by requiring the complete phase out of CFCs, halons, and carbon tetrachloride by 2000 in developed nations and by 2010 in developing nations. Here, methyl chloroform was added to the list of controlled ODS, right? Those particular substances which are depleting the ozone, methyl chloroform was added. Okay. Now, here the phase out of methyl chloroform was targeted to be 2005 in developed nations and 2015 for the developing nations. Now then, after that, another amendment happened in 1992, and that was the Copenhagen Amendment. Now, the Copenhagen Amendment basically further accelerated the goal setting. And it said, it basically included HCFCs now, because HCFCs, as I told you, were developed as an alternative, but very soon it was found out that these HCFCs are also going to deplete the ozone layer. So there was another amendment to the Montreal Protocol, that is the Copenhagen Amendment. It added HCFC. So London Amendment basically when we talk about London Amendment, it talked about the added methyl chloroform. Okay. Copenhagen Amendment added HCFCs, and for the phase out in the developed countries beginning in 2004. Under this agreement or under this amendment, basically, CFCs, halons, carbon tetrachloride, and methyl chloroform were targeted for complete phase out in 1996 in the developed nations, and methyl bromide and the consumption of methyl bromide was capped at 1991 levels. Now, observe one pattern here. Ashirwad, what is ODS? A good question. It is like after Ramayana is over, you are asking who is Sita. Good. So ODS is basically ozone depleting substances. The entire discussion which has happened, my dear friend, has happened around these ozone depleting substances. So unless and until you guys are putting this video on mute, because I don't think you would put it on mute. I'm not that attractive that you will put my video on mute. So basically, unless and until you are putting it on mute and watching, please be aware, wash your face and come back. Okay. So here, when we talk about the Copenhagen Amendment, it basically accelerated the phase out. Now think about it. Earlier, the phase out was scheduled for 2000. Now this accelerated the phase out to 1996. So in a way, it was so very impractical at that point of time. For example, suppose right now you are preparing that I will appear for the civil services in 2025 or 2026. Tomorrow your relatives come over and you say that, no, fair enough, I will give the exam in 2024 itself. Right? So that sometimes it becomes impractical. So this was one of those impractical goal setting. But why was it done? So there's a geopolitical pressure also. Whenever you are hosting one of these summits, one of these meetings, there's always a pressure, media pressure, the public pressure, international pressure, that what is going to come out of that. So that is why many of the countries, they do headline chasing. They set ambitious targets, regardless of whether it will be achieved or not. But they set the target. At least it will say, the newspaper headlines tomorrow will say that Copenhagen Amendment was a massive success because the countries agreed for a phase out by 1996. Countries play this game, right? Even this year, when you had the G20 summit, everyone was aware and everybody would be aware about the pressure that the government faced in terms of the Delhi Declaration, whether there will be a Delhi Declaration or not, whether a Delhi Declaration will be brought out or not. So there is this constant pressure. That is where the countries initially, when you had no ramification and when this all target setting was very new to the world, the countries would set random targets, right? And this is one of the examples of that. But at the same time, this triggered action in the developed nations. Developed nations started phasing out at a faster rate. But here, after that, you had the Montreal Amendment after 10 years of the protocol. Now, this included the phase out of HCFCs in the developing countries, as well as the phase out of methyl bromide in the developed and developing nations by 2005 and 2015, respectively. Now, as this was being carried on, it was found out that few of the countries in the developed nation, North American region, West European region, few of the countries who are signatories to the Montreal Protocol, they are not using these chemicals anymore in any of the instruments, in any of the appliances which are used in that country. But you still had industries producing these ozone depleting substances. Now, if let's suppose US is not using that, why is it that US will produce that? So this was produced, by the way, so that it could be exported to developing nations, third world nations, so that there can be a kind of the export money that they can gain, and they can sell it at a cheaper price. And let's say underdeveloped nation or developing nation, if anything is available for cheaper price, they will buy it. They will think about environmental concerns later. They will buy it. So it was found out that while we are banning these ODS for use, you still have many of the countries who are producing this and selling it to the third world countries. So that is where the Beijing Amendment basically was significant, because Beijing Amendment included the tightened controls for the production and the trade of HCFCs. And bromochloromethane in this case was added. So here, production and trade was targeted. Okay. Now, as a consequence of all of this, all of these various events, the ozone layer started repairing itself, started healing itself. And it has started healing since the time of, or prior to the pandemic, since 2019 itself. You had the ozone layer which had started healing itself. Pandemic further accelerated the healing because the emissions were reduced during the time of the pandemic. But then the healing process was initiated prior to that itself. Now, as a replacement of these HCFCs, methyl bromide, etc., HFC, that is a hydrofluorocarbon, that was being used. That was being used increasingly in all the areas. It was later found out that HFCs, the hydrofluorocarbons, while they don't deplete the ozone layer, but they have a very significantly high global warming potential. The global warming potential is substantially very high in this. So that is when the Kigali Amendment of 2016 kicked into place. So here, goal is to achieve over 80% reduction in hydrofluorocarbon consumption by 2047. Now, it helps reduce the production and consumption of HFCs, potent greenhouse gas, and thus avoid the global warming by up till 0.4 degrees in this century. So it will have a significant role to play in fighting climate change. Now, Kigali Amendment, basically, this is important. This is very important, both for your prelims as well as for your mains. Okay. Now, this Kigali Amendment, basically, you'll find that it had a varying target setting. That is, you had countries divided into three different groups based upon the developmental parameters, what is their technical capability, and so on. So, the first group consists of rich and developed economies like US, UK, and the European Union countries who will start and who have started the phase out of HFCs by 2019 itself and reduce it to 15% of the level that they were using in 2012 by 2036. Okay, they will reduce the amount of consumption to 15% of the 2012 levels. Okay, now the second group consists of emerging economies such as China, Brazil, as well as few of the African countries, where the phase out has to be initiated by 2024 and the usage of HFCs have to be reduced to 20% of the 2021 levels by 2045. Then the third group consists of still developing economies, economies which are not that well doing, and few of the countries in the tropics also. So here you have Pakistan, India, Iran, Saudi Arabia, where you have the phase down of HFCs. The target the phasing down has to begin by 2028, and we have to reduce it to 15% of what we will be utilizing in 24-26. We have to phase it down up till 2047. Okay, so that is basically the target setting, the varied target setting that has been done as per the Kigali Amendment to the Montreal Protocol. Now, as a consequence of this, what has happened? The ozone layer has initiated a recovery. So the ozone layer, basically what it was in the 80s, 90s, and the 2000s, it is recovering. Observe here, the concentration of ozone indicated in Dobson unit. In 1971, this was the concentration of ozone. In 2020, we are at this level, right? But we are improving. So the improvement had started in the 2000s itself, when all the various different parameters and the emissions had been reduced. There itself, the recovery had started. But if the present pace continues, if we continue to basically bind down and clamp down on the production of these ozone depleting substances, it is set for a path of recovery, targeted recovery, and that shall be achieved by 2060. So by 2060, you will have a kind of a significant recovery, and furthermore, by up till the level of the 1970s. So this is what is expected. Now, you basically have an assessment report which is generated. That is how we get to know what is the status of the ozone layer. What are the gases which are released from the various different parts of the world? So you have the UN-backed scientific assessment panel to the Montreal Protocol. Now that panel carries out a quadrennial assessment report. Quadrennial means carried out every 4 years, right? Every 4 years, this report is generated. And this particular scientific assessment panel to the Montreal Protocol on ozone depleting substances, this submits its report, which talks about where how much ozone concentration is there, where how much depletion has happened, and so on. So it confirms the phase out of nearly 99% of the banned ODS. That has been confirmed by this panel, right? So it indicates that if the current policies remain in place, the ozone layer is expected to recover to 1980 values by around 2066 over the Antarctic, by 2045 over the Arctic, and by 2040 over the rest of the world, the ozone will recover to the 1980 values. Now, it was during this assessment report where it was found out, after 2018, it was found out that while the entire world is attesting to the fact that they are not using these ozone anymore. In fact, it was in 2014 itself when it was pointed out that while there was this clampdown and the entire world had attested to the fact that we are not using these ozone depleting substances anymore, the panel found out that there is still secretion and emission of methyl tetrachloride, which is happening from somewhere on the planet. Somewhere from the planet, the methyl tetrachloride is being added into the atmosphere, and it is consistently depleting the ozone. Now, it was very weird. It was very stumping for the scientists to think about it, that when we have banned this, and all the countries are saying that we are not using this in refrigeration, in the air conditioning units. So how is it that methyl tetrachloride is getting created? That is when, in 2018, a much more detailed study was carried out. It was found out that one country secretively is still producing methyl tetrachloride. It is packing it up in the air conditioners, refrigerators, etc., and selling it out to the poorer nations and the nations who are ready to buy those at a cheaper rate. Now, can you guess which was the culprit country in this case? Which was the country which was producing this secretly? Take a guess. Most of you would be correct in this. It was basically China. China was doing that. And the report highlighted it. And the world paid attention to it. Immediately, when you had basically that is how China operates. So China got aware of it. People confronted China. China denied it. China, for that matter, formed a fact finding committee after some days. And it showed those areas in the remote hinterlands of China where that alleged factory was there. And it basically was a clean place altogether. They had cleaned out the entire thing as if it never existed. Right. But thankfully, thanks to that assessment report, now you have a kind of a complete clampdown, which has been achieved. That is why Montreal Protocol is referred to as a runaway success. Okay? Any doubts up till this particular point? Kigali Amendment can be considered as a protocol that help in achieving Paris Agreement? No, Rajan, absolutely not. And Bhagya, why so far as 2028, 2036? That is because the developing nations have their own requirements to be fulfilled, right? And they have their developmental needs. For example, a country like India, we have refrigeration needs. And for those refrigeration needs, we are using HFCs. Now, we cannot be expected to have a research foundation or a research base to such an extent that we can come out with an alternative measure for that. So that is where you basically would not have, that is why the goal setting is a bit lenient. Then can the measures adopted for ozone healing simultaneously help mitigate climate change? Absolutely, yes. And Anurag, all the amendments in Montreal Protocol are a part of the Vienna Convention? Yes, they are. Can we use these chemicals to deplete the ground level ozone? No, my dear friend. Because as I told you, these chemicals, they get reactive at very, very low temperature. We have to mention these conventions and protocols in the solutions? Yes. Does large-scale wars also have the impact on ozone layer? If there is emission significantly, it can. Sometimes you have, for example, chemical warfare, where chlorine gas, etc., have been released. So they will also have an impact. What was the profit for China doing so? Yashi, China could basically sell, for example, an air conditioner. If you are using modern chemicals like HFCs, let's say it is priced at 30,000, you are using a banned chemical which you are able to manufacture cheaply, you will price it at 10,000, you will flood the international market with that. Everybody will buy those Chinese air conditioners. So there, China gains by that. Why ozone repair when there is no winter for polar zones? That is, Vivek, because these chemicals, ozone depleting substances, they get triggered into chemical action at absolutely low temperature. So if the temperature is a bit higher, that is when during the polar summers the temperature is a bit higher, that is when the reaction is not very significant. Shweta, okay, Shweta, my dear friend, you have had this persistent question. For pre and mains exam, PPT and current affairs is sufficient? Yes, my dear friend. Dhanraj, can we say that environment and ecology is connected to the international relations subject? It drives, the global geopolitics drive the realities of this portion. It always does so. Even right now, when the Conference of Parties 28 to the Framework Convention on Climate Change is happening, global geopolitics is at play. And Devansh, I have answered that. And Kumari, why we don't see such strong multilateralism in case of solving other environmental issues? Because in other environmental issues, you have to convince the people that don't emit those emissions from the vehicles that you drive, the big vehicles that you drive, the industries that you operate. And that is where US simply backs out. US has backed out even of the Montreal Protocol. US is not one of those countries initially who was a party to that, right? So countries like US, if let's suppose they back out of the Paris Agreement, we will study later that when Barack Obama was the president, he was very instrumental in bringing all the countries on the platform and agree to the conditions of the Paris Agreement. Then Donald Trump represents a very large constituency of US, the Republicans. Now, Republicans, they have never believed in that entire concept of climate change. They feel that climate change is a hoax, right? So that is why when you hear his speeches that people are driving electric cars, but those it doesn't give you that much fun as compared to the diesel vehicles that America is known for, the petrol vehicles that America is known for. So basically he triggers that sentiment. So the entire country, many large portions of that, they still believe that climate change is a hoax, right? It is a kind of a conspiracy theory. So in that case, the countries are not ready to adhere to it because it will require them to change their lifestyle, which nobody wants to do. And how Atlantic hole happened as CFC was found around living related? No, if that would have been the case, then in Antarctica no hole would have been there. It is the air and atmospheric circulations, and because these ozone depleting substances, they are persistent in the atmosphere for a very long period of time, that is why this air circulation carries them over to the polar areas eventually, and that is where they interact. Okay, Shibam, have to remember all the amendments. See, for your mains examination, I'll tell you what kind of a question can be framed from this. A question which can be framed is, talk about the success of the what is Montreal Protocol. Why has this protocol been successful as compared to the other international agreements? So there, if you are able to mention, not in detail, but the London Amendment in one line, the not in detail paragraph, London Amendment, Copenhagen Amendment, Montreal Amendment, Beijing Amendment in one line, you will have an advantage which your competition won't have, right? Kigali Amendment in itself is very, very important. That is a different question can be framed from that. Can the oxygen produced due to breakdown of ozone be used for respiration? Gaurav, absolutely yes. Kigali implement, yes. Pooja, that is correct. Vivek, I have answered that question. Santosh, how can we include these amendments in mains answer writing? I think now, Santosh, you know what kind of question will be framed. And Femina, is the goal set in Montreal Protocol and its subsequent amendment based on common but differentiated responsibility? Yes, that is one of the principles. But also at that point of time, so you had developed and developing nations. Both of them had different goals. That was one of the reasons, right? And Dhanya, I like your lecture, your teaching. Thank you, Dhanya. Humble gratitude. And how CFC works in cooler conditions. So that is the chemical compound. So it is used in chemicals or solvents or refrigerants as coolants. So that is where the property of it is to react at very low temperatures. Okay. Right. And I think I've answered all of the question. And Tanmay, there is no one good thing about the ozone depletion. No, my dear friend. And Rajan, why only the region on Arctic and Antarctic ozone depletion is high compared because of very low temperatures above that area. And in October, there was a news of large ozone hole detected over Antarctica, which is persistent. Over Antarctica, it is there. It is not as if Antarctic ozone hole will disappear during the Antarctic summer. The ozone hole is still there. That is why you have the assessment report, which tells you that over the region of Antarctic, it will be recovered by 2066. It will be recovered over the region of Arctic by 2045, as per the present progress. Okay. Shallow, there is polar stratospheric cloud provide the base for the CFCs. Yes. You have these polar stratospheric clouds which are present in the polar areas in the lower portion of stratosphere. It is there. The polar stratospheric cloud is a very cold cloud. So you have classification of cloud systems as well, warm cloud, cold cloud systems. I won't go into the details of it, but it is a very cold cloud system. And that is where these ODS, these substances, they end up forming condensates. And it is in that low temperature that they get reactive. Ananya, what China did was producing the ozone depleting substance secretively. When it had said that it is not producing it anymore, it was still producing it secretively, which was caught by the assessment report. In winter, the ozone hole will recover? Absolutely not. Ozone hole and black hole are same. No. Right? Is there any option to speed up recovery? All automatically it is getting recovered. Just that the ozone depleting substances, if it are not used anymore, it will recover significantly. Okay. Why it would take more time for Antarctica than Arctic to recover? Okay. That is a question of geography also. Basically, the reason why you will find that over Antarctica, not only is the hole much more massive, but the hole is very regular as compared to the Arctic. That is why Arctic is expected to recover much faster. And all of it is basically based on the air circulation patterns. If you observe the region of Arctic, Arctic is surrounded by land masses. Now, there is significant variation in the jet stream movement, the polar vortices which are created. So, as a result of these influence of land masses, the air mass movement over the region of Arctic, that is not regular, that is always distorted. But when we talk about Antarctica, we are talking about a large continental mass surrounded by uniform water body. So, the air circulation around Antarctica is uniform. That is why the ozone hole there is much more prominent. It is fixed, it is regular, whereas over the Arctic, you have much more variations which are present. And ozone hole, because of the influence of the other warmer air in the region of Arctic, warmer air produced by the land masses, that has automatically reduced the amount of depletion in that area. Okay, right? How the ozone hole recover in 2065? As in, the depletion has stopped. Understand how is ozone produced? When you have oxygen molecules in the stratosphere, when they are exposed to ultraviolet rays, these oxygen molecules, they combine to produce O3 or ozone. So if you are not depleting it anymore, slowly and steadily you will have more production of ozone, and in those many years that entire concentration of ozone molecules will be refurbished. Okay. Is the UV rays property is straight line, or it can enter Earth and cause human life threat or the depleted area? Generally, above the depleted areas, you have a greater exposure. And though you have the depleted areas which are prevalent across the planet. How many marks should we target to fetch from all? Ideally, for GS paper 1, 2, and 3, you should target around 110 to 120, somewhere plus minus 5. If you want to secure good rank, GS paper 4, 130 plus, essay around 140 to 150. That should be a target. Okay. Now, can we move ahead? Why it happened in cold region? Chandrasekhar, again, I will reiterate, these CFCs, they are active, they are chemically reactive at a low temperature. Not every chemical is reactive at room temperature. I hope we are aware of that particular fact. Not every chemical is reactive at low temperature. Few of the chemicals, if you have to carry out the reaction, you have to increase the temperature. Few of the chemicals, if you have to carry out a chemical reaction, you have to reduce the temperature. CFCs have a property where they become reactive at a very low temperature. Where do you experience very low temperature? Over India or over Antarctica? Over Antarctica, over the region of Arctic. So over India also there will be some depletion, but the greater depletion will be triggered when you have very low temperature. That is why you have polar depletion. Is that understood, Chandrasekhar, now? Okay. Now we move ahead with the various different government's initiatives, the various different initiatives launched by the government in order to tackle, in order to combat the air pollution. Right. Now, the all of it basically, and I will tell you later on in the second last module when we talk about the international conventions, you have to understand that there was a convention, a conference rather, which was held in 1972. There was a conference which was held in 1972. That is considered to be the mother of all the various different climatic conferences. And this was the Stockholm Conference. conference. Sir, I think if we score marks in the range, as you said, we will not only qualify but also get top ranks. Obviously, I think that should be your aim. Please don't keep an aim that I will simply straight away somehow scrape through. No. You have time if you are appearing for the exam 2025 onwards, all of those. For those appearing in 2024, your aim should be that I should clear. Those of you appearing in 2025 onwards, if you lower your goal that I will simply clear off, you are basically doing injustice to yourself. Please don't have that. You have got a head start. There is no reason why you cannot find your name in single digit or double digit rank. That should be the attitude, that if I will compete, but it is not just to secure a government job. I want a cadre of my choice. I want a service of my choice. For that, you need a double digit or a single digit rank. Get that. That should be the goal. Write it somewhere in the piece of paper, stick it in front of the wall. That is something which should remind you on a daily basis. Stockholm Conference of 1972 was held. Now, this Stockholm Conference of 1972 basically talked about the fact that the entire environment and the planet Earth is at risk. Risk of what? Risk due to human interventions. You have three threats which were identified. You have triple threats which were identified. What were the triple threats? You basically had pollution, climate change, and then you also had loss of biodiversity. Why I'm telling you this is because I want you to look at larger picture here. So these triple threats were identified, that we need to tackle these threats as a global community, as the governments of the world. We need to be able to tackle this. Now, as a consequence of this, India was also a party to this conference. India was also in attendance. And you had the Indian government at that point of time. You had the Prime Minister, late Srimati Indira Gandhi, who made very strong statements that how India can be a world leader in terms of combating climate change. And it was, remember, I don't know if you are able to recall that or not, but basically it was during that time when you had Project Tiger, Wildlife Protection Act, all of them were launched. So it was a consequence of this Stockholm conference that you had various climate actions initiated by the government. Amongst them, you had the Wildlife Act of 1972, Water Act of 1974, and you also had the Air Act of 1981. You had the Forest Act of 1980 as well. So these were the various initiatives that were already taken. Now, Air Act of 1981, which was passed, talked about controlling the air pollution. It included the Central Board for Pollution Control, right? So that was given the power. CPCB, Central Pollution Control Board. CPCB was given the power to monitor the amount of air pollution carried out by the various industries and to find out whether they are sticking to the norms or not. So that was done by the Air Act. But after that, you had more regulations which came in. You had fact findings which was done. You had air quality monitoring which was done. You had the change of system where ambient air, that is the surrounding air, rather than finding the amount of pollution at any source, random data collection was done in order to understand what is the pollution level. Okay, so here if you take a look at it, first of all, CPCB, which was formed under the regulations of the Water Act, right? Whenever you come across any of these boards for any of the subject, one thing you have to keep in mind is whether it is statutory or non-statutory. You would have studied it in polity about statutory and non-statutory. Statutory means what? Established as per the statute, as per a law, established as per an act of the parliament. Non-statutory, formed as an organization, society, etc. So CPCB was established under the Water Act of 1974. It is a statutory body. It was entrusted with the power and function of the Air Act 1981 when this Air Act was passed. Right? Earlier, CPCB only had under its jurisdiction, under its purview, to control the water pollution. Later on, the aspects of air pollution was also added. It provides technical services to Ministry of Environment, Forest and Climate Change. It coordinates the activities of various state pollution control boards. And it is a kind of an apex organization of pollution control. Now you had the coining of the term of ambient air quality, which was done. Ambient means the surrounding, how polluted or how clean my surrounding is. So that measures the quality of outdoor air in our surrounding environment. It is typically measured near the ground level, away from direct sources of pollution. Okay. Now, then you had the Air Act 1981. Now, this Air Act basically was enacted to implement whatever were the propositions that were arrived at the United Nations Conference on Human Environment, that is the Stockholm Conference of 1972. Now, you don't have to remember or go through each and every part of this Air Act. Just a broad overview would also do. So, the Act's framework is similar to that of the Water Act of 1974, very similar, whereby you have to control the amount of emissions that you carry out into the atmosphere. You have to basically uh, in a way, take care of the stringent measures, the regulations also. Now, the Act expanded the authority of the central and the state boards established under the Water Act, that is the CPCB, that their role was increased to the Air Act also. States not having the pollution control boards were required to set up air pollution control boards. An advisory committee was also constituted. Now, all industries operating within a designated air pollution control area must obtain a consent or a permit from the state boards, right? So the state board will actually give the permit that, okay, what is the industry that you are operating? What is the amount of emission that you are expected to carry out? Is that amount of expectation with meeting the regulation levels or not? So that will be carried out here as per this act. And states are required to prescribe emission standard for the various industries. They are expected to set up the emission standards that in my state, all the companies, all the industries which are operating have to adhere to that. So industry and automobiles, after consulting the central board and noting its ambient air quality standards. Okay. Now, then you had the 1987 amendment, which further strengthened this act and the regulations. Now, the board might close down a defaulting industry. The pollution control boards, they have the power to close down a defaulting industry or a plant, or may stop the supply of electricity, water supply, other infrastructural supply might be stopped if that particular industry or company is flouting the norms, is violating the norms. Now, the 1987 amendment also introduced a citizen suit, a litigation which could be filed by the citizens into the Air Act and extended the act to include noise pollution. This is a point important for prelims. That the Air Act 1981 extended the jurisdiction of the Central Pollution Control Board even into the area of noise pollution. You don't have a different noise pollution act. The provisions of noise pollution are monitored as per the Air Act 1981 itself. Okay, so that is something you have to necessarily keep in mind. Okay, now the other few measures about the monitoring. So in 1984, National Ambient Air Quality Monitoring was initiated. It was renamed as National Air Monitoring Program. 4 air pollutants were monitored at that stage: SO2, NO2, suspended particulate matter, and residual suspended particulate matter of the size 10 microns, what we refer to as PM10 now. So these were basically measured. In 1985, it was extended to various different states, right? And in 1994, National Ambient Air Quality Standard was introduced, that this is the amount or this is the kind of air quality that we need. Furthermore, in 2009, you had National Ambient Air Quality Standard, which was revised. 12 pollutants were introduced in this, and you had industrial area, residential area, eco-sensitive area. They were monitored differently. These were the 12 pollutants which were monitored as per NAAQS. Do you need to learn this? Absolutely not. Please don't learn this. I would have written this, but I don't think there's a need to write. Please don't learn this. This is just for your awareness sake, that these were the pollutants which were being monitored, including sulfur dioxide, nitrogen dioxide, particulate matter of PM10, particulate matter 2.5, ozone, lead, carbon monoxide, ammonia, benzene, benzopyrene, arsenic, and nickel. These were basically being monitored. Now then, in 2014, another major change was done. Why the change was done? The change was done because, again, if you would visit any major city, or if you would roam in your city itself during 2011-12, you'd find various large billboards which would tell you that the ozone level is this much, the lead level is this much, sulfur dioxide level in your city is this much, nitrogen dioxide level in your city is this much. Now, an ordinary citizen like you and me, how do we infer that if that is within the safe limit or not? If someone tells you that sulfur dioxide concentration is 32 microgram per meter cube, is it good? Is it bad? It is very good. Or is it very bad? How do you know? We don't know. So, in order to remove that discrepancy, what was done? In 2004, you had a kind of a number that we will track 8 pollutants now. And based on that 8 pollutants, we will find out that what is the level of pollution. We'll find an index. And if that index is high, means level of pollution is high. If that index value is low, means level of pollution is low. So one number, an idea about the pollution. One number, color code was associated. So here, the air quality index was introduced in 2014 in order to simplify this. Now you will observe that it is much more simplified version of reportage that you hear in the news, that okay, the AQI numbers in Delhi have increased to 400, AQI numbers here are 250, right? So that you get an idea that what is the level of pollution that you are basically witnessing, right? So it is a tool for effective communication of air quality status to people in terms which are easier to understand. It transforms complex air quality data of various pollutants in a single number. So these are the 8 pollutants which are tracked. This is relevant for your prelims. Okay, this is something that you need to be aware, that which are the 8 pollutants. PM10, PM2.5, NO2, these are measured on a 24-hour average, ozone on an 8-hour average, carbon monoxide every 8-hour average, sulfur dioxide, ammonia, and lead. Okay, NH3 is ammonia. So based upon these readings and based upon these measurements, a number is arrived at. One number, one color, one description. So if the AQI is between 0 to 50, air is good, right? It will have minimal impact. If the AQI is from 51 to 100, satisfactory, but you will have minor breathing discomfort. Think about it. In Paris, if the AQI numbers go beyond 100, beyond 50, they ban the movement of vehicles in Paris. Think about doing that in India, where on an average the AQI number is always close to around 200, right? Now, if the AQI is between 101 to 200, breathing discomfort for people with lung diseases, asthmatic problems, etc. Then 201 to 300, air quality is poor. 301 to 400, very poor. And if it reaches 500, it is severe. So when we talked about the graded response action plan, that can be a way forward. That graded response action plan basically talks about that. Let's suppose the AQI has reached 200. We should have a standard operating procedure that if this mark is triggered, we will take these kind of actions. If, let's suppose, 300 is triggered, we will take these kind of actions. So that is basically the GRAP, the graded response action plan. Now, we have also managed. So this has basically made it much easier to track and convey about the pollution. Generally, you will find that the more polluted areas are in the region of northern part of the country, and in the southern part of the country, because of the reasons that we have discovered, we have discussed, along with the fact lesser population density, movement of winds, population is widely distributed and dispersed rather than being concentrated in one area, the frequent occurrence of rainfall, large green coverage in that area. So that is why in the southern part of the country, the air is comparatively much cleaner. Okay. Now we have also managed to develop a kind of a forecasting methodology where we feed the inputs to a system and the system generates the predictive level of pollution in the coming days. Now, what is the benefit of it? The benefit is for the administrators, for the bureaucrats, for the policymakers. Now they can make policy decisions based upon the future prediction. And that is what is referred to as SUFFER. SUFFER is basically, again, relevant for your prelims. SUFFER is basically System of Air Quality and Weather Forecasting and Research. Okay, India's first air quality checking model. It provides current and advanced forecast of air quality, developed by Indian Institute of Tropical Meteorology in Pune. Pollutants which are monitored are PM 2.5, PM 10, ozone, CO, nitrogen oxides, sulfur dioxide, benzene, toluene, xylene, mercury. All of this is measured. Now, this you can basically choose to omit, not ratify this much, but you should be having an idea what SUFFER does. It is a forecasting tool. Okay, right? Now we move ahead with the other kinds of pollution, that is water, land, and noise pollution. Before that, we take a break. So we'll take a break now. 15 minutes, I think, should suffice. Pollution. Which keep on happening for certain new technologies, for example, which come into the place. Now always keep an eye out for that. Okay, and in also your day-to-day current affairs, you come across, for example, events of land pollution. How is it that the land pollution can be damaging, etc. But if I have to summarize the portions relevant for your prelims, so here questions from bioremediation have been asked, will be asked. Silent zones, the what of it. Okay, then after that you can have the aspect of when we talk about point and non-point sources of pollution. Then after that you can also expect a question in this from the area of diseases caused by pollutants or contaminants. Remember the portion of bioaccumulation and biomagnification that we have studied? I hope you guys are still remembering that, right? Yes? Okay. So here, bioaccumulation and biomagnification. Biomagnification. Okay. So these are some of the key areas from where, and as we go ahead into the PPT, that is where I will also be highlighting that this particular slide is relevant for your prelims or mains, as we have been doing. So that is going to help you significantly. Now then, in the mains examination, for the mains portion, legislations, if there have been any recent amendments, okay, recent amendments. Then, for example, You can also have a comprehensive kind of a question that what are the purposes or the objectives of National Mission for Clean Ganga, right? Those kind of questions can be asked. Bioremediation is definitely asked many times. Remediation. Then e-waste management, plastic waste management. In this, we will study the latest amendments which have been made. Okay. If there is more amendment which happens by the time that you appear for the examination, I am sure you are smart enough to look into that. Okay. Then the concept of integrated waste management. Waste management. What are the various processes involved in that, right? Then the concept of EPR, or extended producer responsibility. Here also amendments or recent amendments to legislations. Okay. So these are the areas from where you can expect a question in the prelims and in the mains. And I don't think I need to stress it furthermore that current affairs development is very, very vital. Okay. Generally, the type of questions that you find to be asked, you have some questions which are very static, straight away picked up. In a way, I won't say that UPSC picks questions from the PPT. I'm nowhere as presumptuous as that. But if you have read the PPT, you would be confident enough to answer those static questions. You have some questions which are straight away from the portion of facts. Straight facts. If you know it, fair enough. If you don't know it, you don't know it. For example, this year you had a question. Now, I had suggested many of the people to watch the documentaries. Those of them who did that were able to solve that. But basically, you had questions, for example, that which of these animals uses a stick of wood in order to fish out the ants and in order to take ants out of the bark and then consume. Orangutan was the answer. Which of the animals, by the fluttering of the wings, is able to indicate to their partners where the location of the food is? The answer was honeybees. So this kind of factual question, if you are aware of it, fair enough. But if you are not aware, you are not aware. But don't get worried by these questions because 99.999% of the candidates are not aware of that. So these factual questions will never make a difference. But sometimes what happens is, let's suppose you have an amendment in terms of the plastic waste management rules. Now there, plastic waste causes many problems, right? You have microplastics creating problems of bioaccumulation, biomagnification. So you can have a question or associated with accumulation and magnification being asked because that plastic waste management was in discussion, right? Previously, in the mains examination, UPSC has asked very, very direct questions. Very direct questions in the sense they have basically asked questions such as what are the key changes brought in the Solid Waste Management Act? That's it. As direct questions as that. What are the changes? What is the concept of extended producer responsibility? So these direct questions are also to be framed from this area. Okay. Now, Gulam, now I think you are aware that when we talk about the environment, what kind of, so you have a basic static question, you have few of the factual, current affairs based, and current affairs based static also. And Suvarna, Our Planet documentary helped me to answer this question. Yes. So remember, we talked about that. If you, I don't know if you attended the previous sessions or not, but I would have recommended that also. This year, green hydrogen was mostly in the news. Green hydrogen question was asked. In the mains examination, a question was framed from there. So it is not as if these are unexpected. Green hydrogen question has been asked. Chances are that it will be asked again. For example, right now, Conference of Parties number 28 is happening. Conference of Parties for Convention to Climate Change. Now, whatever things that we arrive from that, whatever things come out of that, questions can be asked. For example, last year Mangrove Alliance for Climate was arrived at. Now chances are that next year you can have a question from Mangrove Alliance for Climate. Okay. Yes, Devansh, you should not set a target that one documentary a week. Those documentaries should be a kind of your de-stressing, pressure releasing kind of an exercise. Don't sit and watch those documentaries with a copy and pen in your hand. You will spoil everything there. Just be explorative. That is the suggestion I give you. Even when I say how to read Atlas, I tell everybody, be explorative. Explore the options. Explore what is the world around you. I'm sure you won't be aware about how the species, they have adapted to the changes around them. How is it that a small species like a lizard could survive, but the dinosaurs could not? How is it when you have large mammals who could not survive? The entire Pangea was a desert, but these lizards survived. So that is something that you will gain from the documentary, and it should be a kind of a grasping experience for you. Okay. Anushka, yesterday in KBC, one question came related to bird. Name bird which has small in size, is shiny. The hummingbird, is it? Yes. Okay. So hummingbird, I hope you are aware, is basically also having a very distinct wing movement. The normal birds, they have a wing movement which displaces the air backwards. This is just a kind of a factual trivia that when you have the normal birds, they displace the air backwards. That is how they are able to move forward. Hummingbird has got a hovering ability. They, just like helicopters, they are able to stay in the same region and tap into the nectar. So that is where their wings, they behave in an opposite manner. They displace the air forward so continuously that they are able to stay in the same place. Um, what are the other documentaries other than Our Planet, Santosh? You have the documentary of Our National Parks also, which is narrated by Barack Obama. Life on Our Planet, Night on the Planet. So if, let's suppose, you have seen BBC Earth, or if you have a subscription of that, these documentaries keep on flooding into your area. But please don't start spending money that I have to watch documentary, because that fellow in the online session had told me that I need to watch documentaries, so I will spend money on that. Don't do that. Freely available resources, use that only, more than sufficient. Okay. On YouTube, Aditya, you'll find this on YouTube, most of them. Now, then we come across, first of all, we initiate the discussion for water pollution. Pollution of water. For that, again, I would say, just like I told you up in the case of the air pollution, in order to understand the pollution of water, you don't have to go anywhere. You have to look around yourself and you will find that. Right? So here, water across the planet has been polluted. But when we say water across the planet, which kind of water are we talking about? When we talk about the distribution of water across the planet, basically, you'll find that around 97.5% of water present across the planet is salt water. That is the oceans, the seas of the world. They are saline, they are salty in nature. So that consists of 97.5% of the water on planet. Right? Around 2.5% is basically fresh water. Now, even that fresh water is further subclassified into various different parts. For example, the ice sheets, the ice caps in the polar areas, all the icebergs that you see, the frozen areas, even, for example, the frozen glaciers, etc., they contribute, or they account for close to around 70% of the fresh water. Right? All those ice caps, glaciers, etc., they account for 70% of the fresh water. Now, 30% of it is in the groundwater. All the rivers, lakes, ponds, etc., that you see, they contribute. The atmospheric vapor, soil moisture, etc., they contribute only 0.4% of the fresh water which is available. Okay, so that is basically the distribution of water across the entirety of the planet. Okay, this is the, and on this also a question has been asked in the examination twice in prelims. Okay, once time back, but I'm not concerned about any kind of question asked prior to 2013-14, but basically, even in the past few years, this question has been asked. Okay. Now, when we talk about water pollution, we humans, we are very capable species of the planet. We humans basically have survived the very significantly competitive and cutthroat race for survival between the reptiles and the mammals. Right? So we are very capable. We, being the capable species, being the smarter species, we have managed to pollute salt water. We have managed to pollute the ice caps. We have managed to pollute the groundwater and, well, the surface water. If you have to take a look at the pollution of surface water, I would suggest all of you take a trip to Delhi. Take a look at Yamuna, River Yamuna in various places. Or go to Mumbai. Take a look at River Mithi. Or go to Hyderabad. Take a look at River Musi. Or if you don't want to travel, just explore your area. In your area, you will find that level of pollution. We have managed to pollute each and everything. I hope you are aware that even in the Alps, even in the Himalayas, we have already discussed that we have carried out black carbon deposit due to the amount of pollution. In the region of Alps, in many of these frozen glaciers, you'd be surprised to know plastic pieces and plastic sheets have been found embedded in the glaciers. Think about it. How prolonged has been the practice of pollution. But when we talk about water pollution can be carried out. For example, let's suppose you have a river. Yes, previously Ganga, but then by all various different accounts, if you take a look at it, Ganga slightly has improved. It is not the cleanest river of the world yet, but Ganga, the health has slightly improved. And pandemic had helped significantly for that also. But there has been an improvement in that. Is there any technology for converting salt water into fresh water? Absolutely, yes, Chituri. You have various desalinization plants. Remember the much talked about trip of the Prime Minister to Israel, where there was that much publicized public bonhomie between Netanyahu and our Prime Minister. Now, they were basically, it was at that point of time that India finalized the deal with various desalinization plants because Israel basically masters that technology. Because if you take a look at the region of Israel, it is present in the region of Negev desert. They don't have access to clean water. They have that desalinization method where they can convert that salt water into fresh water. Similarly, we are now using that desalinization technology and a newer desalinization technology in areas such as Lakshadweep, Andaman, in order to fulfill our long-term water requirements. But the only problem in that is that it is not still very, very cheap, so that it can be commissioned in a decentralized manner. We have to bring that price down. Okay. Yes, we have provided that tech to Maldives also. Yes. Now, here, when we talk about the pollution of the river, now, pollution can be carried out by various sources. For example, let's suppose on one side, you have the farmlands where you are growing various different types of crops. You have the farmlands, let's suppose. Now, from these farmlands, you have agricultural runoff into the water. Right. Let's suppose more farmlands, more agricultural runoff, all the fertilizers that you apply, everything that you provide. Right. So nitrates, phosphates, potash, with the irrigated water, raindrops, etc. You would have seen this also. Many of the times you don't realize that this is polluted water, but you would have seen this sometimes when there is rain. After those of you who have actually lived near an agricultural field, or if you would have had a good fortune to work in an agricultural field, you would have basically observed that, let's suppose, after you apply the fertilizer or pesticide, and if there is a sudden amount of rainfall, you would observe that the water which runs off has got slight foam buildup on it, right? Small foam particles, they build up on water. These are basically your chemical contaminants which are getting drained out, right? So here you will have the entire region, wherever these are situated, you will have the source of pollution, right? It is not coming from one point, it is getting distributed across the entire area. Let's suppose in this region, further higher up that you go, or further different area that you go, let's suppose you have here habitations. Generally, across the sides of the rivers is where you have, in the floodplains is where you have the settlements of slums, right? The migrant laborers, and this is true for all parts of the country. Migrant laborers, when they come there, obviously they cannot afford to live in the central business district. They have to live somewhere on the outskirts. So they settle down in the shanties and the huts and the hamlets that they build on the sides of the river. Now, there, they don't have the proper sewage system, do they? They don't. They cannot afford it. So that is why all that sewage, kitchen waste, human fecal matter, all of that is basically provided to the water. Here also, what do you see? It is distributed in the entire area. It is not as if the source of pollution is only one. Then, and again, this is a kind of thing that India has been trying to root out in the past few years. And thankfully, we have been partially successful in doing that. But still, early morning, if let's suppose you are traveling by road, you are crossing a river, or traveling by train, crossing a river, or simply walking around, crossing the river, what do you find? You'll find tens of people lining across the riverside for discharging themselves, right? The human sewage, the human fecal matter. Now, that is our contribution to the rivers. The rivers provide us clean water. The rivers provide us with a source of life. What do? We basically pollute the rivers by discharging our fecal matter. Now, if let's suppose there are 10, 50, 20 individuals who are doing that on a daily basis, it is not as if all that fecal matter is coming from one portion or one source. It is getting democratically distributed, if you can use that term. Everybody is free to do that, and everybody does do that. So these are the sources of pollution in water. But sometimes you will also find the fact that, for example, you have very large, let's suppose, industries, very, very large industries which operate. Okay. Now they will have one outlet. From that outlet, they discharge the waste. Now there, all that waste is coming out from one point. In this case, all the waste is coming out in a distributed manner. So that is why when we talk about water pollution, the sources of pollution can be classified into point sources and non-point sources. Point sources, from one single point, you have that discharge. Non-point sources, well, you are free to pollute wherever you want, right? So when we talk about the non-point sources, for example, the streets of the cities, the rural homes, the runoff from the forests and the trees, the cropland, agriculture, so it gets accumulated everywhere and anywhere. You can have that pollutant entering the river system, entering the water system. So you don't have a particular point from which the pollution is happening, right? So that is what is referred to as non-point sources. And then when we talk about industrial effluents from one particular portion of an industry, etc., as you can see, as the waste is discharged, as the waste is basically dumped into the water, these are your point sources. Okay, so that is basically the difference in the terms of the sources of pollution. That sources of pollution which pollute the water, they are classified on this particular basis. Can we call non-point sources as distributed sources? Absolutely, yes. So that is the case of water pollution. Now, here, freshwater pollution is again surface pollution, also groundwater pollution, also. All of that is freshwater. When we talk about point and non-point sources, sewage pipes, industrial outlets, we know that industrial waste outlet is a point source, right? This is a point source. This is a non-point source. if the sewage pipes are coming out from each and every place, as is the norm in our country, rather than coming out from one sewage treatment plant. But you have natural sources also. For example, when we talk about the forests, right? If it rains significantly, much of the nutrients in the waste automatically gets dumped into the nearby rivers. So the rivers, so you would have observed during the rainy season, for example, if ever you have gotten an opportunity to look at River Ganga during these months, during the month of December and January, if you have not never gotten that opportunity, do visit the region around Rishikesh, Dev, Prayag. If obviously when right now when you clear the examination, I think that is when you will get that opportunity. If you visit that area, you will find that the water is almost bluish green, very, very clean, almost transparent. But visit the same region in the month of July, August. It is muddy, murky, brownish. Why? Because when there is excess amount of rainfall, it carries that discharge and waste from all around and dumps it into the water. So you have natural sources of pollution also, and you have the anthropogenic sources or the human sources also. Right? Now, after this, when we talk about the groundwater pollution, so that was the river pollution. When we talk about the groundwater pollution, now, even the groundwater has been polluted quite substantially. Now, when we talk about groundwater pollution, why does that groundwater pollution happen? So there are certain reasons. One of the reason is that when the polluted water seeps into ground and enters an aquifer, that is, it results into groundwater pollution. So let's suppose you have polluted water in a lake or in a pond, in a large lake or a pond in your city, and you would attest to the fact that how polluted these are, right? So let's suppose you have water here, and it is contaminated, it is very polluted. Now here underground you have the rocks, the permeable rocks within which the groundwater is present. Now these polluted waters can enter here slowly and steadily. They can get into there and they will pollute the groundwater. Sometimes what can happen is when you have open dump, right, or waste is discharged onto the land, waste is accumulated in the land. We have talked about it yesterday also, that one of the favorite peeves that we have is basically wherever we see an empty land, either we grab it or we dump waste into it. We cannot see a land empty. It makes us Indians very uncomfortable that how come a land is empty? We have so much of population. Either build a house there or I will start throwing garbage. So we have basically open dumps spread all across the country. And here, when you have these open dumps, so basically what happens in these open dumps is, it is, as you would have seen in the region of Delhi, etc., that these open dumps are very massive structures. These are not small structures that you're talking about. These are very, very massive structures overall. So in these open dumps, the waste imposes a pressure, a weight on the lower layers. So the lower layers, they start getting compressed. The lower layers, they start getting pressed down. Right. So as the lower layers, they start getting compressed, what happens? You have various chemicals which are secreted. For example, when you throw out the waste, even if there is a lead acid battery, people throw it out in the same waste. You would have seen people throw out all sort of chemical compounds into the waste. Now, where does that chemical compound go? I know we are not concerned about that once we throw the waste. It is the matter of Sarkar-e-Hind. It is the matter of the Almighty God. They will take care of the waste. We are not concerned. We just need our cities clean. And for that, we are dumping the waste on the cities. Rest is the responsibility of the government. But where will those chemicals go? Those chemicals, eventually, they start seeping underground. And those will contaminate the groundwater. Then there is another factor, another aspect, and that is the over exploitation. exploitation or extraction of groundwater brings contaminants along with it. So basically, what is the case? What the region of Punjab, Haryana, Western UP, in particular, these areas are facing, where the amount of rainfall is less, and they tend to overcompensate that shortage of water with extraction of groundwater, where almost every farmland has got tube wells and they keep on extracting water there. So what happens as a consequence? Let's suppose when we consider the groundwater, in most of the regions, it is stored in permeable rock structures underground. Permeable rock structures which are present and which are prevalent underground, let's suppose. Now here, if you install a kind of a pipeline, that is what is done for extraction of water, that is what you do. You install a pipeline, isn't it? When you install a pipeline and you basically start extracting water, here, you start bringing out water. Now, what does that lead to? Initially, the water which is present nearby, that gets extracted immediately. But after a period of time, what happens is that the more water that you extract, basically, the compounds, the various minerals which are embedded within the rocks, those minerals also start coming along with that. Those particular minerals also start coming along with that. That is the reason why in the region of Punjab, in the region of Haryana, in the region of Western Uttar Pradesh, when you extract groundwater now, you will find fluoride, arsenic, sometimes even cadmium, zinc, and in certain cases, even uranium coming out. And before you spend all your energy typing the question that can that uranium be utilized for production of energy? No, it is not that much amount of uranium. It is just a contaminated amount, which can basically impact your health, but you cannot extract utilizable uranium out of it. So all of that is leading to significant issues as well, right? Now, as you can see, manganese in the region of Punjab, the groundwater of Punjab, manganese, copper, aluminium, mercury, uranium, lead, cadmium, chromium, selenium, zinc, all of these are present. Almost all of these are present now when you extract groundwater from Punjab. So think about it. When you are now extracting this groundwater and spraying it across the agricultural land, what you are doing is you are spraying these minerals or you are spraying these contaminants into the agricultural fields, and that is what will be taken up by the plants. So the crops that are grown, the crops from the grain bowl of the country, they contain these contaminants, right? They include these contaminants. So when we consume these, we carry out bioaccumulation. That is why the elderly population, the young population, they are getting impacted by it severely. Health impacts are quite significant over a period of time. Okay. Now, then let us take a detailed look at the various different causes of water pollution. When we talk about water pollution, here we talk both about the marine pollution also and also the freshwater pollution. One of the major sources of this water pollution is oil spill and accidents. So, oil in the world, one from one portion of the other in the world, how is it transported? With the help of the tanker ships, the container ships, and in certain cases, the pipelines, right? Now, that is how oil and gas is transported. Now, sometimes what happens is that the fuel, the oil that these ships are carrying, due to accident, due to certain malfunctioning, due to collisions of the ships, this oil starts to seep. Now, oil is lighter than water. So, oil being lighter than water, it stays on the surface, right? It stays on the surface. It spreads over the surface. And thereby, the fishes, and if it happens in the shallow regions, it will, that oil, the slick, crude oil, which is very darker in color, very viscous and sticky in color, that crude oil is basically refined. Then you get the petroleum, kerosene, diesel, etc. that you use, but the crude oil is very dark, slicky, sticky material. That crude oil, when it starts leaking, so all the species in that region, they get that coating of oil. Think about it, that the marine plants, they won't be able to carry out photosynthesis because they have that coating. The Many of the marine species, they have that sticky coating which they can't get rid of. They don't have the hands to get that away. Many species, millions of individual organisms, they face massive die-offs. Western countries, Western economies, and Western oil companies such as Exxon, Valdez, etc., they have been known for carrying out these oil spills in various parts. Once Exxon Valdez carried out that oil spill in the Gulf of Mexico, it took more than a decade for Gulf of Mexico to recover. So this oil spill is significantly dangerous. Also, what it does is basically it blocks the availability of oxygen, because remember I told you that from the ocean water and air interface also there are exchange of gases such as oxygen and carbon dioxide which happens, where the ocean water is able to take in that amount of oxygen. But when you have that slick oil covering on top, what do? That oxygen is unable to penetrate through. So you don't have that oxygen going through anymore, right? So that is where that supply of oxygen is cut off. Okay, so that region turns into a kind of a dead zone. The waters become devoid of oxygen, so you have almost hypoxic waters where you don't have any dissolved oxygen, and it turns into a kind of a dead zone. Okay, so that is basically this oil spill creates dead zones. Dead zones. And how does it create dead zones? I hope we are now able to assimilate that by basically carrying out these oil deposits on the species, where the species will face the die off, and also stopping the air water interface region. Now, this is about the crude oil that the ships are carrying when they leak. Sometimes, you also have the case of these large merchant vessels and merchant ships, or any of the larger ships, even your aircraft carriers for that matter. Any of the large ships they run on a special fuel. The engine operates on a special fuel. I hope we have this basic understanding that whichever vehicle you operate, the engine oil is different from the petrol diesel that you use, right? So engine oil is different. So the ships use a different type of oil for the functioning of its machineries, and that is what is referred to as bunker fuel. If that starts leaking, it is much more devastating. It is much more disastrous. It is much more disastrous than a normal oil spill that you come across. It is very, very dangerous when you have that bunk. So that is why whenever you observe that the ships, they undergo a collision, or the ship simply stops functioning and starts capsizing and starts to sink, the biggest fear amongst the ecologists, the marine biologists, everyone, the biggest fear is that the bunker fuel should not start leaking, because if that starts leaking, then that can spread. It is heavier also, so it will have the pollution extended to multiple layers. So in order to remove this oil spill, what do? Now these oil spills, by the way, they can lead to massive and large scale coral bleaching in a large area, because much of that oil, when you talk about bunker fuel, that can have a slick deposit over these corals. Immediately the corals will, the zooxanthellae will die off because they can't carry out photosynthesis anymore, and the corals will die off. Massive coral bleaching can be happening. So what are the impact of oil spills? You have the species getting impacted, the biodiversity. Marine plants are unable to function, so the dissolved oxygen level starts going down. These oil that stays on water, that water basically it prevents that air water exchange of oxygen, so the water starts turning hypoxic, creates dead zones, leads to massive coral bleaching, impacting further biodiversity. So these are the various factors, right? Now, how do you treat that? How do you get rid of that? So you have various things such as, okay, bunker fuel is very heavy than the weight of the ship. Can that be possible, my dear friend? I understand the question, but can that be possible that the weight of your fuel is heavier than the weight of the vehicle? Can it be possible that the amount of fuel or the engine oil that you're using in your car or in your motorbike or in your scooter, can that be heavier than your scooter? Think about it. Is that logically possible? Bhagya, is that logically possible? Absolutely not. Absolutely not. So that is why it won't be possible that the bunker fuel is heavier than the ship, but it is heavier than the crude oil that it is carrying. Vivek, this red color is the basic filtered oil or the refined oil which gets spilled over. You want me to write the impact in points? Okay. Hmm. Sometimes it is healthy for the muscle exercise if you start writing something on your own also. That is healthy for the hand muscles also. So try it out sometimes. It is actually fun. And trust me, regardless of whatever the perception is, in the mains examination, you only have to write. At that point of time, even if you call me, I won't be able to enter the exam hall. But nonetheless, prevents air water exchange, reduces the photosynthetic activity of marine plants, reduces the oxygen produced and organic compounds produced. Then, after that, causes massive coral bleaching, then also enters the marine food chain by bioaccumulation and magnification, and biomagnification then creates dead zones, kills, here only you can write, kills planktons, leading to starvation of many species, many organisms. Right, these are the things. Okay. Yes, biodiversity is threatened, dead zones are created. Now, how do you clean that? How do you get rid of that? So there are various ways. One of the method is by utility of skimmers, by using skimmers, right? So one of the method to do that is use of skimmers. Now, what are skimmers? So skimmer system basically is what? Is that with the help of a kind of a net, a kind of an impermeable layer, you run it against the surface. Coral bleaching I have already included here, Parveen. So here, in the case of the skimmers, what do? You basically run it against the surface. Just like, for example, you have something light on water. How do you separate it? You basically separate it with a hand by running your hand on top of it. Just like that, you have these skimmers where generally a string is attached in between the ships, and the ships, they start to move. So that that layer or that accumulating region, that starts collecting that particular oil. So that can be used. Then if you have light oil, very light oil, which tends to float and which is flammable also, localized burning can also be carried out. Localized burning, burning, that can also be carried out. Then, other than that, you can also use specific microorganisms such as oil zapper, oilivorous, etc., where what they do, they break down the complex hydrocarbons, right, into simple carbohydrates. So oil consists of hydrocarbons. So many of these microbes, what they do, they keep on working, they keep on breaking this, and they will break the complex hydrocarbons. So you have microbes. That is a method of bioremediation. That is, with the help of biological processes itself, with the help of microorganisms and the biological processes of decomposition and degradation itself, you are breaking down the contaminant. So with the help of bioremediation, what do? You basically carry out with the help of oil zapper, oilivorous, right? So oilivorous, etc., basically they carry out this particular degradation of the complex hydrocarbons. They break down that oil so that it can get decomposed and digested naturally. So these are skimmers. Again, I would say skimmers are, for example, think about uh, in a simple case, think about it. You have a bucket of water, right? In that bucket of water, here you have water which is filled up. On that water, let's suppose you have some of the dust or ash which falls. What do? You basically skim it off. If you want to drink that water, if you want to use that water, what do? You skim it off with your fingers, your palms itself, you skim it off, you remove it off, isn't it? So that you can then dispose it, then you have a better, cleaner water. Just like that, because oil is lighter, oil tends to float on top of water always. Oil tends to float on top. So that is where you, with the help of these skimmers basically include large sheets, large fabrics. Those fabrics, tethered fabrics, they are attached with the boats, and as the boats move, those skimmers, they accumulate those waste. This is also used for removing plastic waste, and the plastic pollution from the oceans is also removed by this particular process. Okay. Now, then you have other sources of water pollution also. Yes, Sardari, like on tea, the Malai layer. Yes. See, I did not want to give that reference, but if you are able to relate to that, fair enough. On large scale, appeal for hair donation is done during oil spills. Why is that? Because it is these, sometimes even sawdust is sprayed over this oil, so that you can have these particular materials which start absorbing the oil, excess amount of oil which is there. So that is why sawdust is more pertinently used rather than the hair. So that is where they start absorbing the oil. And when you have, let's suppose, sawdust which is sprayed over, or even hair for that matter, which is sprayed over, distributed, each of those particles will absorb a lot of soil, a lot of that oil, and then as a kind of a solid, you can then easily remove it off. Oil zapper is a microbe, a microorganism, which decomposes or degrades the oil. Normal microbes, they don't have the ability to degrade or decompose oil. So that is why you have very specific microbes which work upon the degradation of oil. Okay. Localized burning is basically that in that localized area, you control, because the oil is going to float on top, you put fire on that, because it is only the oil which will burn, water does not burn, right? I hope we are aware of this basic fact also, that if you put in a jar or in a bucket, if you have water on top of oil, you burn that oil, the oil will continue to burn. As long as there is oil, it will continue to burn. Water does not burn. So same principle is used there also. Okay. Now, then we talk about the other sources of water pollution. Sewage and wastewater. Well, these are something that you are all aware of. Now, these untreated sewage and untreated wastewater, they will contaminate the water with excess amount of nitrates, phosphates, as well as other different contaminants. And this can always lead to almost all the various different pollutants, always can lead to eutrophication and harmful algal bloom. When you carry out water pollution on such a large scale, eutrophication and harmful algal bloom are the possible outcomes, the expected outcomes in that. Mining. Mining is also one of the ways in which the water keeps on getting polluted. How? How is that the case? So, for example, let's suppose you have the mines in a region. Let's suppose you are carrying out mining. Let's suppose this is a large rock structure from where you are mining rocks, or let's suppose you are mining coal, anything like that. Now, how do you carry out mining? You blast it off, isn't it? You put explosives in this. In a controlled explosion, you blast it off. Now, you use water also in order to control the amount of dust which is emitted. In order to lower the temperature in these rocks, you spray it with a lot of water. Now, as a result of that, what happens? All that water basically carries on the minerals such as mercury, various different silicates, etc. And it simply moves into a river or a pond or a lake, or in certain cases, even seas and oceans. So that is why mining is associated with heavy contaminants being generated and laid off in the water. Then you have agriculture. And here we are talking about agricultural runoff. So agricultural runoff basically, so in the agricultural field, as I told you, you spray the various insecticides, fertilizers, chemical pesticides, etc. And then if it rains, then what happens? All that will be runoff. All that water will start moving off, right? So that is the case of agricultural runoff. Then you have marine dumping of waste, because again, humans are mostly same everywhere. We think about it that if we dump the waste in the oceans, then nobody will hold us responsible. We are not accountable. It is planet's responsibility to clean that. Or if someone points out that why you have polluted that, it is their responsibility to clean that. So in the coastal areas, particularly, you have the dumping of solid waste. Due to unsustainable tourism practices, you have dumping of that marine waste. Now, it is very recently that many of the shipping companies, the merchant vessels, etc., they have agreed to have a sustainable waste management practices. But otherwise, generally, the practice which is still followed by many of the shipping waste vessels, what you will come through, is that all the waste that is accumulated in their long voyage, they would dump it in the ocean. All the excess amount of heavy oil, etc., which is a waste, they dump it into the ocean. Because out there in the ocean, who is there to control that? Right? Who is there to govern that? Who is there to have that jurisdiction there? So that is why that is the marine dumping. Agriculture is basically here, Dhanya, when we say agriculture, we are basically talking about agricultural runoff. So when I say agricultural runoff, let's suppose, what do I mean by that? Agricultural runoff. So by agricultural runoff, let's suppose that in a farmland you spray various different fertilizers, chemicals, etc. Now all those fertilizers, chemicals, etc., while they will pollute the land also, now if there is rainfall, These fertilizers, chemical pesticides, etc., they get accumulated with the water and they are drained off into the nearby pond, river, or the lake. So that basically means the chemical fertilizers, pesticides, right, herbicides sprayed across the fields gets carried by the surface runoff, water to get accumulated in lakes, ponds, rivers, etc., even seas and oceans. Is that understood now? Now, then you have the leakage from landfill that we have already talked about. Landfill is basically a kind of a solid waste disposal methodology where the process, the modus operandi, the method of operation rather, in the case of the landfill is what? That, for example, if you have to dump solid waste, what do you do is, we will study landfill in detail later on. So let's suppose you have to dump solid waste. So you dig a kind of a massive depression on the ground. You dig a kind of a massive depression in the ground. And on top of that, you basically, in this, you dump the waste. Ideally, you should cover it with a thin layer of soil on top. That is what is referred to as a landfill. Now, in that case, where all the waste is present here, that waste will have its weight getting imposed. And due to the pressure, that waste will give out certain leachate, such as certain kinds of chemicals, harmful contaminants, etc., which can then penetrate into the groundwater, can pollute the groundwater. Sometimes what can also happen, that excess rainfall in this area, if it happens, now you would have observed in the nearby dump sites, if excess rainfall happens, so the rainwater will carry some amount of extract from that waste dump also. So that also, that runoff may be carried out by the drains into the pond or the lake or the river or the sea or the ocean. They will pollute that region. Industrial effluents, well, the industrial discharge, they are a source of pollution. And then you also have radioactive waste. Radioactive waste is generated from the industries which use certain chemicals. It is also generated, the radioactive waste is also generated, for example, the from the medical sector, from the hospitals. Certain of the hospitals, they use these materials, which are certain chemicals, which are radioactive in nature. From the nuclear power stations, there also you have waste which is radioactive in nature. Many of the vessels, the shipping vessels, are nuclear powered, so there also sometimes nuclear waste can be discharged. For example, you had the Fukushima nuclear disaster. I hope we have heard about Fukushima nuclear disaster. Fukushima nuclear disaster was triggered due to a massive tsunami which rocked the region of Japan in almost a decade back. Now, that is where you had the contaminated water which entered into the nuclear reactor, and that water leaked. Radioactive waste leaked. So that is a kind of a radioactive waste. So even sometimes accidents, sometimes when you have these accidents, they can also cause the leaking of that particular radioactive waste. Okay. Now, this is again a chart that you can refer to for the purpose of your aspect of your prelims. Yeah. That is the causes of pollution and basically the sources of pollution. This, I would not suggest you to learn it off, but just be aware of it, that humans, what is the cause of pollution that they carry out, what are the types of pollution that they carry out. So for example, when we talk about nitrates and phosphates, they are carried out because of overuse of fertilizers and so on. So that is basically caused by them. Then when you suddenly release hot water from many of the industries, you will find, especially the steel plants, wherever the steel plants operate, they will simply discharge very hot water. Now that hot water can simply reduce the dissolved oxygen. Very hot water can reduce the dissolved oxygen, and basically that causes significant amount of issues. Dead zones are created as a result of that. Sedimentation of particles also creates various pollution. So this is what you can go through. Now, after this, the health cost of, when we talk about groundwater pollution or the groundwater contamination. Now, groundwater is contaminated by various different types of contaminants, various different types of effluents, and each of them will have their own detrimental impact that they experience in terms of the human health and the human body. So when we talk about the various different contaminants, for example, fluoride contamination, something which is getting very prevalent across the northern Indo-Gangetic plains, that is the fluoride and arsenic contamination. Now, whenever you have fluoride or arsenic contamination, it impacts the body. Now, fluoride, what it does, fluoride, by the way, not many of us are aware of that. You would have seen various different TV ads that use this particular toothpaste. Your teeth will shine brighter than the sun. Use this particular toothpaste, you won't require tube light in your homes anymore. Your teeth will be the source of light. One of the chemicals, one of the compounds used for that toothpaste manufacturing is fluoride. And excessive consumption or accumulation of that fluoride in the body, that is very, very harmful. That is where the bones, they start to weaken, they start becoming brittle also, right? So brittle bones, teeth, joint impairment. So you suffer from fluorosis, as it is referred to. Fluorosis. Then arsenic. Arsenic contamination is again very prevalent. In the areas where the groundwater has been overtly exploited, arsenic contamination is also very prevalent. Now, what does that lead to? It leads to Blackfoot disease, and various issues in the gastrointestinal tract also is led by that. So, arsenic contamination leads to Blackfoot disease as an example. Okay. Then, for example, iron contamination. Iron contamination leads to hemochromatosis, which can lead to liver, heart, and pancreatic damage, as well as diabetes. Increased amount of nitrate contamination. Nitrate contamination leads to a kind of a reaction with the hemoglobin of the blood, and where the blood is unable to give enough oxygen to the body. And that is going to impact the young ones particularly more, where the body starts, basically the various cells, they don't get enough oxygen supply, and the body starts turning blue, right? So nitrate contamination is associated with what is also known as blue baby syndrome. Blue baby syndrome. Okay. Then you have various other types of contaminants also. For example, you have the cadmium contamination. Cadmium contamination again impacts the joints, and particularly the joints of the limbs, that is the legs, the hands, etc. Now, there in the joints, generally when we have the joints, the joints are able to move easily. That is why we are able to move. That is why we are able to wave off our arms and legs, etc. But with the cadmium contamination, this process becomes very painful. And that is what is also referred to as itai itai or ouch ouch disease. So this is what leads to itai itai or ouch ouch disease. Itai because of the region in Japan where it was first observed and reported, and ouch ouch, the name associated with the flexing of the limbs and that pain which is caused. Then you have mercury contamination. Mercury contamination leads to nervous disorders also, and that is what is referred to as Minamata. Minamata disease. Okay, then so these are basically few of the diseases which are caused by the contamination. This is relevant for your examination prelims. Match the following kind of a question. Okay, match the following kind of questions can be asked from there. Yes, Minamata convention, we'll take a look into it as well. So that is for Minamata disease and getting rid of mercury contamination. Okay, so these are your various different contamination related disease that you should be aware of. Now we come to the river pollution. When we talk about the data about the river pollution, first of all, you don't need to be aware about the exact amount of pollution in every state, in every river. I just want you to observe the trend of pollution. Now, here, if you observe the trend, Maharashtra in 2009 gained the top spot. It was the most polluted, followed by Gujarat, followed by UP, then followed by Karnataka. Observe in 2015, Maharashtra regained that top spot, very closely followed by Assam, followed by MP, followed by Gujarat, and so on. 2018, Maharashtra, Assam retained the top spot. Even now, Maharashtra and Assam, they tend to dominate. So, why is it that in the region of Maharashtra and in the region of Assam, do you have so much amount of pollution? What are the causes? What could be the possible causes? So when we talk about the causes here, so basically, one of the prime causes why the rivers in our country are getting polluted and are increasingly polluted is because of the lack of proper sewage system, the sewage network. We don't have enough sewage treatment plants or STPs. Because when it comes to the manufacturing or the building of the sewage treatment plants, it is a time consuming process, right? It will take you around 3 to 4 years, 4 to 5 years, and it is not very lucrative for the local politician to flaunt that, look, in the 5 years for which you have elected me, I have built a sewage treatment plant. They don't get that much amount of traction. And if your local politician comes to your area and tells you that in this region I have constructed 2 sewage treatment plants, now there will be less pollution in the river, fair enough, you will hear him out. Maybe you will offer a clap. Other politician comes to your area and tells you that, look, if I would have been in power, I would have given you this much amount of money, I would have given you this amount of food, I would have given you this much amount of clothes, maybe I would have given you a mobile phone, maybe I would have given you a scooty, a bicycle, anything you ask in the world, I will give you. Generally, and not generally, almost in 100% of the cases, the electorate will elect the individual who will give out the materials rather than the individual who has built the sewage treatment plants. Right? That is the general mentality of and the general mindset of the electorate. Right? Elections are being conducted even now. You would observe that. So that is why sewage treatment plants has never been a lucrative kind of a construction which has been carried out. Right? So lack of sewage treatment plants sewage treatment plants is one of the reasons why you have such huge amount of discharge of the waste, human fecal matter, sewage waste, etc., which is happening into the rivers. Then after that, if you consider industrial waste in the region of Maharashtra, for example, agricultural runoff in the region, for example, even in Maharashtra and Assam, agricultural runoff. Then after that, you also have waste, dumping of solid waste, of plastic and solid waste. Okay. These are the reasons why you will find that the rivers, particularly in these areas, are quite significantly polluted. And as you can see, pollution, for example, chromium, etc., that chromium waste, cadmium, everything, copper, lead, everything can be found in various areas. For example, when you consider the region of Uttar Pradesh. Now, in Uttar Pradesh, you have river Ganga, which drains through the region of. Now, by the way, out of Lucknow and Kanpur, which city lies on the banks of river Ganga? Are we aware of that? Out of Lucknow and Kanpur, which city lies on the banks of Ganga? Okay. The best answer is Varanasi. That is the best answer. I have asked about Lucknow and Kanpur, and the answer that you have given is Varanasi. Very good. Appreciative of that. No, it is Kanpur. Kanpur lies on the banks of river Ganga. Lucknow lies on banks of river Gomti. Now, Kanpur is one of those areas which is significantly, in a way, in that region, is considered to be a hub of the leather industries, the small scale and medium scale leather industries. You will find a lot of them in Kanpur. Now, the leather industries, the leather tanneries, as they are referred to, they discharge a lot of chromium as a waste. You will observe yellowish, brownish, and sometimes even reddish effluent being discharged into the water. And that has been a key source of pollution of river Ganga for a very long period of time. Very long period of time. During the pandemic, when the lockdown was imposed and you had the industries which were forced to shut down, many of these leather tanneries, many of these leather industries, they were also forced to shut down. As they shut down, and as you would have seen at that point of time, immediately health of river Ganga started to improve. And you had a massive improvement, isn't it? So that is why industrial contaminants, industrial effluents, they are significantly disastrous for the rivers. Okay? So if you control that, now you cannot order the shutdown of these industries. Why? Because that means so many people will be left unemployed. Then what will happen if so many people will be left unemployed? Economy will suffer. So that is why you need to have a kind of a slow and steady nudging manner with which you can tell the people that don't pollute, don't contaminate. But along with that, you need to provide governmental incentives for these industries, for these factories to upgrade their machineries. But you know what happens actually out there? In reality, what happens? The government, let's suppose, has brought about a program, a plan, a scheme that this particular industry, with this much, we will give you a kind of a cheap loan, credit free loan for these many crores. You upgrade your machinery. With the connivance of the bureaucrats and the officials, these people, they take that money, keep the old machinery running, right? So nobody, basically they benefit out of it, the officials benefit out of it, but the environment gets degraded. So in order to protect the water, in order to get the water cleaner, you had the Water Conservation Act 1974, which was passed. And it was under this act and the provisions of this act where you had the setting up of CPCB, Central Pollution Control Board. Under that Central Pollution Control Board, at the state level, you had the establishment of SPCBs. State level, you had establishment of state pollution control boards. You had mandate which was given that the states need to set, the CPCB needs to set the requirement about the level of pollution, and the industries need to adhere to that. Okay, so the Water Act 1974 represented India's first attempts to comprehensively deal with water pollution issues and creation of institutional setup in the country. This was the first legislative measure which was passed in order to take control of pollution. Air Act came later, Environment Act came much later, right? So this was one of the first concrete legislative actions which was taken to control pollution levels. The act prohibits the discharge of pollutants into water beyond a given standard and lays down the penalties which can be imposed. It vests regulatory authority in the state pollution control boards, okay, and empowers these boards to establish and enforce the regulatory standard which is expected out of these industries. CPCB was constituted in 1974 as per the provisions of the Act. This is again going to be relevant for your prelims. Okay, and the Act grants power to the board to ensure compliance with the Act, including the power for entry into the various industries for examination, testing of equipments. So the officials, as per the Act, have the power to carry out random checks, right? Take the sample for the purpose of analysis of water for any stream. And the 1988 amendments, they further strengthened it. Board may close a defaulting industrial plant or withdraw the power or electrical supply from any plant which has been found to be defaulting. Okay? Now, then we'll come to the government initiatives, other government initiatives, National Mission for Clean Ganga, etc. We'll come about it and we'll talk about it tomorrow. Saturday, we have an extra class, by the way. I hope that is there in your mind. So that will be all for the session here today. We meet again tomorrow where we further carry out the discussion. And let's take a few questions then. And Sarita, book list for geography optional. Okay. For geography optional, ideally for physical, you can study the book of Savindra Singh. That will be more than sufficient. For physical geography, for Indian geography, you can refer to Kullad, but the data pointers in Kullad are not very reliable. So for that, I would suggest you to rely on the current affairs and the ministry data. Then for models in human geography, Majid Hussain is a good book. Then for perspectives in geography, you can go through R.D. Dixit. And for some economic geography, you can go through the Rupa publication, the thin book, only select topic wise, more than sufficient. Okay. And why Assam saw a large jump in the water pollution levels as compared to the others? So that is basically because when we talk about the region of Assam, the extension of agriculture has happened quite significantly. The population density in certain areas have also increased quite significantly. Then you have setup of industries also. Extension of agriculture bringing new areas under cultivation. Okay. Divya, it's absolutely fine. Where that is just some fun that we have in the midst of the class. It is sometimes it is good to laugh off these matters. And Santosh, why can't we implement strict environmental laws or policies like Switzerland did? Have lesser population as Switzerland? You can always implement that. Here, the problem of pollution is so significant. Problem of population is so significant. Not the problem, but in general, the population size is so significant. Very difficult to monitor. But 50 years down the line, basically we all can foresee in India where the regulatory standards will be much better, because the awareness amongst people, if that increases, if people start treating the rivers, the ponds, and the lakes as their collective resource, rather than this is the property of government, they should take care of it, automatically it improves, right? Bunker fuel, where is manufactured in various different countries. It is basically the engine oils for the various different lubricant systems that a ship uses. Mehul, I just reply to the same answer, same question that Kamlesh asked about how us in Assam river is very polluted. That is because of extension of agriculture. When we talk about the increased settlement, industrialization, all of that has increased in the past decade or so in the region of Assam. If you are belonging from Assam, you would attest to the fact that newer areas on the sides of Brahmaputra have been brought under cultivation. You would attest to the fact that there is increased amount of construction activities. For example, in Guwahati, across the banks of river Brahmaputra, you have a massive construction going on, right? Isn't it? So that is basically, again, leading to river pollution, river contamination. Baldev, marine dumping. What is dumping? You dump something, you throw something. So when you dump waste in the marine areas, that is marine dumping. Whether you carry it out from the coastline, whether you carry it out from the ships. So plastic waste, solid waste, everything that you throw in the sea from the coastal area, that is marine dumping. And leakage from landfill is basically those dug out areas in the land where you dig out the land in order to fill it with waste, right? And you cover that portion again. So that landfill, due to the waste and the weight of the waste, that liquid starts getting secreted, and that contaminates the groundwater. Sometimes you have the runoff, and the rainwater will carry out the contaminants and the waste, and they will carry out to the nearest river. Okay. So let's carry out the discussion tomorrow. We will restrict the session here today, and we meet again tomorrow, and we will continue the discussion. Thank you for being so very patient. Thank you for being forgiving because the class was delayed. I hope we will be able to start the session tomorrow perfectly, picture perfect, on time. With that, I bid you goodbye. We meet again tomorrow. Thank you. Goodbye and good night.